Hello everyone. In this video, we are going to start writing tests for legacy code. But instead of starting with a big feature or a big widget, we'll start small here. Because starting small has its benefit, which I am going to share along with this video. So let's get started. So how do we start small? Basically, we start small by finding a simple bug in an existing app. The reason for finding that bug is because first, it will allow you to start small, and second, it will also fix something in your existing app, which will also provide some value. So at least if you are refactoring or changing a code, at least you can ship to users and make sure that it works properly. So the first thing about finding that bug is try to find that as small as much as possible. For example, someone raised a PR on my repo to fix a typo which I did and I just merged it. So let's try to fix that bug in our code base and see in the emulator where we can find it. So if we go to our to-do app, we can find that completed task, the pop-up shown here, where you can see that there is a spelling mistake. So this is how the most open source project track their issues and PR on GitHub. But if you want to find an existing bug in your app, in your company, you need to find the tracking system they use and then go to the backlog and find the smallest bug as possible, like the typo bug here or some other bugs you can fix very easily. So let me show you in the app. You can find that text here, which is completed task, and it has been a typo there. Now you might be wondering or thinking that why the hell I'm watching this video if I'm going to fix just a typo. Well, just hold on and be patient. You'll start to see the benefit of starting small as we go along this video. So just bear with me. So as a life in general, try to avoid instant gratification and try to have a delay gratification. So we are going to have a delayed gratification for this scenario. So the first thing is we need to find the code exactly where the issue is. And remember, code is never read from top to bottom like a book or a blog. We always read code from the place we start looking for the code first. So there is a great video on how to read the code. I'll share that link into description. So in case of spelling mistake, just search the text and we can leverage the IntelliJ IDEA tool to find that text. We'll use a shortcut called Command-Shift-F and just find the completed task misspell. And here is the one. So when we click on a pop-up menu item, we show a child text called completed text. And this is where we have the spelling mistake. Remember, this project is small and easy to find, but in larger project, you might need to do a lot more digging to find that text in the code base. A good place to check is the localization file. In Flutter, it's an ARB file where all the strings are located and you can trace back where it has been used, or there might be some constant file where all the strings have been put. So those are good way to start. But just to explain the example here, we have just searched the text directly and landed into the page where the issue is. So how do we fix this code? The simplest solution would be go to that text, fix the spelling, and then hot reload, and done. You have fixed the spelling issue. Congratulations. But here is the problem. The fix which we have done right now does not guarantee that someone else won't undo this spelling mistake again, or if there is a merge conflict, this can be overridden by some other conflict. So now when anyone changing code around this spelling mistake, we need an ability to verify that this spelling mistake is not been broken and the same mistake does not happen again. So basically there are multiple ways, but in this case, you can try two ways to write this test. One is test the entire screen and verify this text, and another one would be just verify the small widget. Let's start with one. So we follow the same folder structure we do for the production code. So here our home page is into pages and home. So in test we'll create code folder called pages, and then we'll create a folder called home, and then we'll create a file called home_test.dart. You need to remember that you need to append all your tests with _tests in order to pick up Dart this file as a test and run it, else it won't pick up if you miss that _test. So let's write our first test, which will be basically completed task action is available in menu. We'll have our tester here. Let's make it async. Now how we are going to write this test? From a UI perspective, this is our home screen, and when we click on this menu pop-up item, it should show the text. So in order to test that, we need to first load the home widget, and then we need to find this text by clicking on this. Let's do wait home screen, and then we'll just wait this frame to be settled. Then we need to verify the text which we fix, and we need to find one widget. So in order to find this text, we know from the UI that we need to click on this pop-up item, and then only we can see this text. So first we need to find that pop-up item. So we need to tap on that icon in order to open that pop-up menu and match this text. Without that, it won't show up. So we will tap it on the pop-up icon by finding text, and then pump and settle. Then we'll do pump and settle. But the problem is that we don't have any text or icon to find on a pop-up menu. If we go to our code, we see we are building a pop-up menu from here, and we don't have any icon or a text so that we can find and click on it. And this is one of the common issue come across when writing a test in legacy code, because we don't have that much of keys, or we don't have a widget written in such a way that we can write a test for it. So one of the simplest way would be to add a key to that widget and find that widget in the test. So this is our pop-up menu button, and what we can do is we can add in a key _home_ option, and then we can find that key here, key home option. Now let's run a test for the first time, and you'll see that our test failed, and this is our first error while running the test. This happened because in order to render a text, it required a material theming and scaffold widget as an inherent widget. But since we are loading just a home screen which doesn't have that, it's failing. And this is also like one of the most common issue we faced when writing the widget for the first time. So the simplest solution would be to wrap this widget around material app, which contains all the theming and stuff in order to render home screen properly. And this is why writing a small test is useful, because this will help you understand your dependency graph. For example, I used home screen directly. Now it helped me to understand that whenever I need to have a home screen, I need to have a material app as well. So it's giving me of understanding how the dependency graph is being structured. So now we'll run our test and see, and it passed. Congratulations. Now this is really important why we start writing a small test. I mean, we didn't want to find an easy way to start, but intention was to understand the code base and its dependencies. Now while writing this test, we are getting that knowledge by the first we're understanding that okay, the home screen cannot be loaded alone, it required material app. And another thing is that if we don't have an icon or a text, how do we find that text using these keys? So it's really important to use that key around widget, or you need to have some mechanism to find an icon or a text. So this test passed, but let me be honest with you. In most cases, it won't be that easy, because on a home screen, you will be doing bunch of things like loading a database, calling an API, doing authentication, and most of the time that will be happening inside like in our main.dart. So in most of the case, if you're doing a lot of stuff here by loading database, initializing some libraries, calling APIs, and a lot of stuff will be happening here. So it won't be that easy to run a test and make it pass. So in that case, a better approach would be just to extract the part which you want to test into a widget and just write test for that widget. So for example, our issue was here, the misspelling. So what we can do is we can extract that into a separate widget and then just write a test for that, and we don't need to tab because we're directly testing that. Yeah, there's always a trade-off between two approaches. The trade-off here is that you are able to isolate the small part and able to test it, so that is a good thing. But in terms of legacy code, you are not able to cover that much of a code. You are just covering a single line. So for example, if you run the code coverage around it, and then we'll open up our terminal. I'll just bring you that. So you can see in the home, these are the part of line which we haven't tested yet, and this is the part which have been tested. So we have covered 4.1% of this code base. So by isolating a small widget is very easy, but the trade-off come with the legacy code is that you have covered a small portion of it, and in some cases that's fine if you are going into some small incremental fashion. But let's say if we go back to our previous example of writing test with home screen, now let's run coverage for that, and let's generate the code here, and let's refresh this. Now you see we cover 34.7% of this code because we are loading the home screen. Now covering this code does not mean that you have safety net for 34%, but it's still far better than 4.1%. So in programming, whatever approach you choose, it comes with a trade-off. So in a first scenario, where we are matching just home screen, we are having an advantage of having just small set of tests, like just matching a text and covering 34.7% of code base. This 34.7 does not imply that all your 34% of code is safe, because we have not written that much of tests, but it's far better than having the less coverage we have earlier. But the disadvantage with this approach is it will have a lot of init code, or it will require a lot of mocking and faking the database and API call since it's on a home screen. So the code won't look that good, but over a period of time you can improve that as well by separating out separate component once you have a lot of tests in place. The advantage with the extracting widget is that you don't require much of dependency here. You just extract the part which you require and just write a test around it. So it's one of the simplest and easy way to go. But in case of legacy code, it does not give you much broader range of coverage. It's just a small set of coverage you have. Another advantage of this approach would be that since you have extracted into this widget, you might have an opportunity to find the same text and replace everywhere with this widget. The disadvantage is that since it's cover only a small piece of code, in terms of legacy code, we are not able to cover that much area like the home screen does. So it's in terms of legacy code, it would be a good way to start writing tests which covers more area. Another thing which I described with the home screen was we have a lot of init code in our main or home screen. Like here, for example, we have a lot of init code here. One way to minimize that is to extract this whole init code into a separate class or a module, and while running a test, you just mock it or fake it. So since this completed task cover less part of a code, I'll just remove it and keep it as it, and we'll use home screen as a test here. Another thing is to overcome the issue of init on home screen. In our main.dart, For example, a lot of init code goes here. The first thing is we need to understand the dependency of this code, how much of dependency we require in order to test our home screen, and then just mock or fake those dependency. Now, how to do that? I'll talk more about those approaches and techniques in upcoming videos. So just stay tuned. So to conclude that, start small and avoid the urge to do big things all at once. Starting small allow us to understand the system, domain, and dependency better. That's why starting with a small bug fix is really important. Your first step will always be the hard one, and especially if you are writing your first test, it will consume most of your time, and most developers give up in their first test itself. For example, for me, it took me around 2 months to write my first test app properly for a really complex app. Starting small allow us to fix small problems by understanding system as a whole, and it's give an idea on how dependency are coupled in our code base, and it also gives an opportunity to break dependency for writing test. For example, we see on how we extracted the completed task into a separate widget in order to test that part only. Understanding the trade-off is also really important. It's all about making decision and moving on. I'm here to help you and guide you, but the ultimate decision will be on you based on your project, domain, size, culture, and team. Watch this course like a suspense thriller movie, like a Christopher Nolan movie. If you skip in between, you don't know how you land here. But remember, the end is not important. The journey is important. Also, side projects are really useful for experimentation. You can pick up your old side project and start applying this test technique to it and see how it works, and then you can start using in your day-to-day job. So in the next video, we'll learn how to raise the bar and write more complex tests by faking different data sources like database, API call, and bunch of other things. So see you. So if you like this video, then please like, share, and subscribe. Thank you.